Hey, what's up guys? Once again, welcome back to my channel. So today we are designing a boiler. It is boiler tank in the Solidworks. This is the 3D model of the boiler. So let's start. Firstly, we need to select the all planes and click on show. Then go to the right plane and click on sketch. Then choose the line. Firstly, we need to create a profile for our revolution path. So let me draw the line, horizontal line. Then choose the center point of the drawn line and the origin and make the relation as vertical, which helps us in simplifying the drawing. So let me give the dimension to the horizontal line, which is 1000 mm. It is 1 meter, and vertical distance as 250. Let me increase the dimension. It is 350. So it becomes diameter of 700 mm. It is 0.7 meter. Let me draw another line to make us mirror assembly. What you can say the sketch. Then choose the arc command and draw the arc. Then give the dimension to that arc is, or the r to that arc as 400 mm. Now trim the unwanted portion from the drawing and let mirror the arc the right side with the help of our reference lines or the center lines. Then exit sketch and go to the features, go to the revolve boss and go to the thin features. We are designing a boiler in the sheet metal. So I am selecting the standard sheet size, that is 8.2, which is standard sheet metal size. Then click on OK. Just reverse the direction of the thin feature and we again try it. Then it's OK. Now you can also see the sectional view of our boiler tank. Select the front plane, which is the sectional view from the front plane. Then click on OK. Now we move to our next step. Now we need to create a plane to give the boiler support. So let me choose the reference geometry and go to the front plane and select the distance offset, which we are selecting as 300 mm and click on OK. Let me change it to 250. Click on OK. Now select the latest plane, that is plane 1. Click on sketch. I need to draw the pad plate for our boiler, which is very essential, which performs a very essential role in the boiler, which is the strength of the boiler. So choose the boiler outer shell and take it for the convert entity, and again draw the offset by the 8.2, which is our sheet size. So it will make a pad plate. Draw the reference lines or the center lines by the 15° to both sides and trim the remaining portions. The portion remaining Then join the remaining portion and exit sketch and go to the features, go to the extrude boss and extrude it by the length 180 mm. Click on OK. Now let me change it to 150. Click on OK. The pad plate is generally used for to give the support to the boiler supports. So let me mirror the pad plate by using front plane. Click on OK. Then we need to take again one plane by using the reference of plane 1 by the distance of 20 mm and click on OK. Now hide the unwanted plane. Then select the plane 2 which we lastly drawn and just convert entity the now draw the line, horizontal line, and select the center point of that line and the origin and make the relation as vertical. And then give the dimension as 500. That's very less, so we change it to 600. That's okay. Then draw the vertical line by using the endpoint of that line to the both side and touch it to the pad plate and just convert the pad plate. Exit sketch and go to the features and choose the thickness as 8.2 and reverse the direction. Click on OK. Now our first support plate to the pad plate is done. Then we need to mirror it or the pattern it. So let me choose the pattern and choose the features and distance. So let me choose the distances. So let me choose the number of offsets or the units, which is equal to 2, and distance is I think distance is 105. So let me choose the distance as 105. Let me check. This is okay. Then click on OK. So we need to draw the vertical support between that plates. So let me draw the support between them. So draw two vertical lines and connect the vertical lines and give the dimension from the end to the first line as 8.2 mm thickness plate. So we are selecting 8.2 and trim the unwanted portion. Then we need to do the extrude boss. Click on OK. Select up to next. So it will help to extrude it up to the next surface. So let me mirror our pad plate support. So simply mirror it and click on OK. So we need to draw the bottom support. So let me select the bottom face of the supportive plates. Then we need to draw the rectangle to the starting point to the end point of that pad plate. So let me select the corner rectangles. So select the two corners and make a profile, then exit sketch and go to the boss extrude. And extrude it by the 8.2 mm thickness. Then we need to mirror that total objects, the totally drawn supports to the our right side pad plate. So let me mirror it. Click on OK. Now our boiler support work is over. I need to draw the inlet. So let me take a one plane to the vertical side at above the top side or the at above the top plane. So let me draw the hole diameter or the pipe diameter. Here we are using standard pipe, that is 100 MB pipe whose OD is 114.3. You can search anywhere. This is the standard pipe. So we are using standards to draw this. This is the standard drawing. And exit sketch. Then draw the height of the pipe as 100 mm and the select bottom side as up to next, which can be help at the rounded portions, which clearly fits on the circular portion. So we are selecting up to next. So let me draw the flange on it. Select top face of the pipe. Extrude cut the inside portion of the pipe to the boiler. So we are selecting the top face and using the extrude cut command, we extrude cut the boiler portion or the shell portion. So let me draw the flanges at the top. So let me choose the circle command and draw the circle, random circle, and convert entity at the outside of the pipe, which helps to draw the flange by using pipe OD. So let me extrude it. So go to the extrude boss and extrude it. We are using here 19 mm thickness, which is standard pipe. So here we are using 19 mm flange, which is standard flange. Basic plate of this flange is 22 mm, and after the machining, which becomes 19 mm. So to draw the holes on the flange, we are selecting the top face of the flange. So we are choosing here the 13 diameter. So M12 bolt fits into it. Then we need to select the pitch of the circle. So we are selecting 180 diameter of the pitch or the PCD for the flange, which is pitch circle diameter. So let me pattern our hole into the into the 12 holes, which is standard. So let me extrude cut it. Select up to next, click on OK. For every boiler we using the flange. So to reduce exhaust gases, so we are using the groove flange. So we need to draw the groove for our flange, we also call as U groove. For that we need a plane. This is our fifth plane. So let me draw the U groove shape. Then we can draw the U groove by using revolve cut command. So let me draw the profile of the U groove. So basically U groove is used for the gasket purpose or the wire rope. You can say the ceramic rope also, not a wire rope. This is usually used for the fitment purpose. The ceramic rope does not allow us to pass the gas from the flange, which make a bonding between the upper and bottom flange. So we are choosing the R5 flange or the U groove here. So let me close the profile, and we are using the PCD for that U groove as 140 in dia. So let me draw the profile on the upper flange to revolve cut for the U groove. So select top face of the flange, then draw the circle by using the center of the flange and select the point of our U groove profile and give the diameter as 140 mm. Exit sketch. Then go to the swept cut, select the profile, which is our U groove cut, and our next line is as our stopper circle, and our slot is complete. You also get the slot idea. So this is our boiler design. If you like the video, then subscribe my channel. If you want more videos like that, then subscribe my channel, hit the like button, and enjoy the next videos like this. So thank you.